Maitland Supernovage, and my video is on polydentate ligands and their role as chelating agents. So in this video project, I'll be going over an introduction, defining ligand, defining polydentate ligand, defining chelating agent, their uses, and my sources. Introduction to what I'll be covering in this video project. Polydentate ligands have the ability to act as chelating agents. This ability produces chelates or chelate complexes, all of which I will define later in the presentation. This ability serves many functions in the world of chemistry and biology, playing important roles in many crucial processes like that of roles of handling heavy metal poisoning, EDTA, oxygen transport in hemoglobin, chlorophyll, and vitamin B12, all of which I will go into further. So first, to kind of just build a background, I'm going to define what a ligand is. So a simple definition is that a ligand is molecules, atoms, or ions that attach to another molecule in turn to form a complex. Ligands act like electron pair donors surrounding an electron pair acceptor. This electron pair acceptor is usually then a transition metal, and I've kind of provided this little graphic to show that, where you can see kind of the attachment. The term ligand itself comes from the Latin term ligare, which means to bind. An example of a ligand is water or ammonia. Those are both simple ligands. And then within that, types of ligands include monodentate, which means it's through one atom, bidentate, which is two atoms to attach, and then polydentate, which we'll be discussing more, is through multiple atoms. Okay, so now I'm going to be discussing what is a polydentate ligand. So a simple definition is that it is a ligand that bonds via two or more atoms or at two or more points. The term polydentate, it comes from the Greek word meaning many teeth, poly, many, dentate, teeth. And then as these ligands have more than one bond, the complex formed is cyclic, or it means having a ring, which you can see in the picture to the right. And then this complex is then referred to as a chelate or a chelate ring. An example of this is EDTA, or ethylene diaminotracetic acid, which has 6 donor atoms and can also be referred to as a hexadentate ligand. Now I'm going to be defining what a chelating agent is. So simply, this is when a polydentate ligand bonds to a metal ion and creates 2 or more covalent bonds, or a chelate complex. The polydentate ligand is referred to as the chelating agent, within this complex. So the term chelate comes from the Greek word for claw, and was first used in 1920 by Sir Gilbert T. Morgan and H.D.K. Drew. A chelating agent is able to attach to an ion without putting strain on its own structure when forming heterocyclic rings. And then these complexes have also been seen to be more thermodynamically stable. And then you can kind of see in the picture where they used lobster claws to kind of represent what chelate, means in the word claw. Now I'm going to discuss uses. Of those uses, one of the major uses of chelating agents and chelation therapy is in the medical field with EDTA. It can be seen as a treatment for heavy metal poisoning. EDTA is injected in the body, and then it binds with heavy metals in the blood, which then all can be excreted out through the kidneys. Right now, potentially, it's being seen as a treatment for coronary artery disease. There are some beliefs that EDTA could be used to attach to calcium and plaque, which builds up in arteries, and then it could be also removed. Possibly as an antioxidant, it may be able to target cholesterol, and it may aid in inflammatory diseases such as lupus, arthritis, etc. But right now, treatment with EDTA is still kind of disputed and argued, and further study is needed to understand the risks and benefits of this treatment. EDTA is also used in soaps and detergents. It can create complexes with calcium and magnesium, which both inhibit the way soap and detergents work. It can be used in food preservatives. The natural enzymes in food that basically spoil food have transition metals within them, and EDTA will kind of capture these transition metals and then act as a preservative. And it can dissolve calcium carbonate, which is seen in hard water stains or buildup. EDTA again can kind of like capture and remove the calcium, which will remove the deposits. And then it is also used as an anticoagulant. It can displace the calcium ions that are needed for coagulation to occur, and this is really helpful in storing blood or in blood banks. Chelation and chelating agents are also seen in the heme group of hemoglobin and its connection to iron, nitrogen, and oxygen. It's also seen in chlorophyll, where there's also a porphyrin chelate, the same as in the heme of hemoglobin, where it's bonded to magnesium, and in vitamin B12, where this complex is bonded to cobalt.